Hello, friends. Part 2 of your podcast on section 1.6 in the Algebra 2 book. Just finished looking at examples 1 and 2 here. Do these and bring them to class tomorrow. We'll go over them then. All right, example 2. Now we have compound inequalities. Why is it compound? Because there are two numbers on either side of the variable expression and two inequality signs right there. So think of these as an equation where you've got something to do to three sides instead of just two. In this example here, we are just graphing. So we want to be in touch, and it's the same rule with when do we use an open dot? We use it right here when we have a less than or a greater than, or this one, another less than, and we use a solid dot when we have a greater than equal to. The rest is, well, let's just make sure we know. Okay, so this says -3 is less than x. All right, so I put an open dot at -3. So that means x has to be greater than -3, going this way. And this part says that x is less than 1. So again, my open dot at 1 and less than. So what am I going to shade? I'm going to shade all the places where both things are true. All right, so that's what we call an and inequality. It's an and inequality because everything that's shaded is both greater than -3 and less than -1. All right, get some of that mess out of there so you can still see it. On this one, still a compound inequality, says x is less than -1. All right, and this is called an or because the answer is anything that's this or this. Okay, and you can see what they did. All right, again, you've got number 3 to practice. So try that on your own following the example, and we will go over it in class tomorrow. All right, you got a bunch of rules here, and this just basically says, in a nutshell, you can use all the same inverse operations that you used on the equations that we've already done and that you did all year long in Algebra 1. The only thing that's different is if I either divide or multiply. So if I either do this, which is dividing both sides, notice I reverse the inequality sign. Or if I multiply, like I did here, by -1, I reverse the inequality signs. All these other examples, add, subtract, multiply, or divide by a positive, it's exactly the same thing that we did with equations. Okay, so this is the only new thing that you've got to pay attention to. All right. Okay, we got more practice here. Now we actually got to do some algebra, and they actually walk through the steps here. And these notes are good, especially those of you that have struggled a little bit in chapter 1 so far. Understand what these little sentences mean. I'm not telling you have to write them out. I'm saying when you actually do the steps, read the explanation that goes with the step, and make sure you understand. And if you don't, that is a good question to ask either in class or come see me at conference period or in a free period, whatever. Okay, so now we got to do a little algebra, and you can see from the original, they subtract 9x from both sides, so that gets rid of this, and then they subtract 5 from both sides, which gets rid of this, and that ended up here, and I divided by a negative, and notice they reversed the inequality sign. Okay, and once I had the answer, I should be able to graph it. That's what I did earlier in the problems. You've got example 4 and 5 here to practice on that paper. All right, last minute of podcasting here. Now I've got a compound inequality, and notice this is where like I said earlier, I'm going to be doing something to all three sides. So here, I add 2 to the middle. I add 2 here. I shouldn't be doing it here. Sorry about that. Add 2 here, add 2 here, and add 2 here. And notice when I do that, I end up with these numbers here, and the -2 just cancels out. Then I divide everything by +5. So I get just 1x in the middle, -1 and 2. And then I can take this whole inequality and graph it here. All right, we'll see you in class tomorrow. Make sure you've done all these practice problems. Where is it? Right there. Those are the last 3. Do them up. See you in class tomorrow.